Okay, so I'm just gonna quickly fly through this page on page 13 and follow along if you haven't. So if you are new here, right? Like this is just cross multiply and divide. So we multiply diagonally the two numbers that you can multiply diagonally and divide by what's left. Okay, and that's how you get that. And so I will do this in real time so that I get a sense of where you're at. So that's 8. We don't have units, right? Yeah, I will do attendance of you online folks in a bit. There you go. So you cross multiply here, 16 times 18, right? And you divide it by 12. That's 24. Okay. Over here, you cross multiply here. So it'll be 8. Make sure you show your work. Don't just have your final answer there, okay? That's important. 8 times 56 divided by 64, that's 7. Here you cross multiply these two. Those are the only two that can be cross multiplied like that. And it's 18. So that's 27 times 36 divided by 18. It's 54. Here the only two that you can cross multiply are here. So watch how I write it. You can just write one of them in brackets and that's fine. There. 5. That's 60, right? This one. So sometimes I want you to also put your thinking caps on, right? I see that 3 times 5 gives me that. So 12 times 5 would give me 60, right? So you know x is supposed to be 60. Okay. And, oh, you weren't seeing that, were you? My apologies. Yeah, so 3 times 5 would give you 15. I see that pattern. So you would have to multiply this one by 5 also. Only then are they equal, right? So the two that multiply are here. That's 3 times 4, 60, divided by 5. That's 276. Okay. Here, 25 times 200 divided by 40. And it goes on, right? So this is just a skill. Notice at the top it says build your skills at the top of this page. It's basically saying you're going to need this skill, so you should get really good at it. Okay. It's not going to be, this is not what this unit is about. You're going to need this to answer other things in this unit. Okay. All right. So let's continue with our notes. We're basically working through the booklet slowly. I will introduce, I will show you, for instance, I will find it first. Every once in a while, I inserted a blank page with lines. So for example, if you go to page 18, then there's 18A right next to it, 18A. So 18A is a blank page for us to add stuff if we need to, right? So I can use that later on. So if I tell you go to page 18A, then that's where you go. You just find 18 and it'll be right after 18. If I tell you to go to 26A, you find 26 and then it'll be right after it. All right, let's go to 14 here. And underline, highlight if you can, okay? So a lot of the important terms are on the side here, okay? Ratio, a comparison between two numbers measured in the same units, okay? So it's basically, we're talking fractions, right? It's a fraction basically that has the same units. So a couple of things for fractions, you're going to have to think of reducing. we will always try to reduce. We will always, it should have no units because the units will cancel out, and we want no decimals. Okay, so this is basically just my addition to ratios. And remember, your study sheet, for you it's green, right? That green study sheet, you quarter it, right? Four boxes on either side, and then we start to fill in what examples and whatnot, okay? So this is the new skills. When a carpenter bonds two pieces of wood with epoxy resin, that's just a glue, okay? You're gluing together two pieces of wood, right? She must first mix the epoxy with the hardener. This might make no sense to you, but once you're into crafting and mechanics and whatnot, they'll have like special, you buy glue and it comes in two different tubes like this, right? They actually have different colors. Sometimes it's red and black. And so you mix them together, and then you want to stir that compound together, and that creates a very, very strong glue, right? And so you got to mix it appropriately. If you don't mix it together appropriately, then it's not going to work for you, right? So you want 10 parts of epoxy, right? If she says we're going to mix it a ratio of 10 to 1, that means that we want 10 parts of epoxy to 1 part of hardener. This ratio can be written as 10 to 1. So 10 to 1 also means the same as that. And it also means the same as that. So basically, we can say 10 to 1, or we can say 10 to 1 like that, or we can say 10 to 1 like that. Okay. Notice that if you flip this into a fraction, make sure that the first number goes in the numerator and the second in the denominator, okay? All right. If the carpenter wanted to use 150 parts of epoxy, she would need 15 parts of hardener, right? This would give her a ratio of 150 to 15 between the amount of epoxy and the amount of hardener. So you can write it to 150 to 15 or 150 to 15 like that. But what happens is that this ratio, right, this ratio can be simplified to this again, right? So it's basically simplifying fractions, right? Simplifying fractions all over again. Like if you divided both of these by 5, right? Or 15 in this case. 15 is very obvious, right? If you divided the top by 15, you would get 10. If you divide the bottom by 15, you get 10 as you get 1, right? Because 15 divided by 15 is 1. So that's what they've done here. And so you basically will always end up with a simplified form of 10 to 1, no matter what you do, no matter how many you mix together. Hang in there, guys. I'm going to do your attendance in a bit. I just want to get to the part where I can hand it off to you a bit. It is common to express ratios as fractions when doing calculations. So a ratio is something like this, right? So 15 to 2, for example, we would rather want to write it 15 to 2 like this, right? We would want to convert it to a fraction when working with it. When you state that two ratios are equal, as they are in the following equation, you have written a proportion. So this is a proportion, okay? That is a proportion right there. It's just two fractions that are equal. Except for us, one of these will be unknown, right? There are 4 numbers, one of them will be unknown to us. Okay. Let's continue, next page. page 15. Okay. So Charles works as a cook in a restaurant. His chicken soup recipe contains, and then you've got the ingredients here. Okay. He wants to make the recipe at home for his parents. To reduce the recipe yield, he needs to know what the ratios are between the quantities and the ingredients. So you're basically, so this is basically, this serves a lot of people, right? This is a big portion, right? It serves a lot of people. And it makes sense because this is a restaurant, right? So their recipe will be, you know, a lot of stuff that you're mixing together in this big pot, right? Because you're going to make it for, I don't know how many people they expect, but it's a restaurant, right? So we expect a big, this will yield. That's what yielding means. Like if you mix stuff together, it yields certain amount of food, right? So you want to reduce it. You want to reduce it, make a smaller batch. Okay. He needs to know what the ratios are between the quantities. So what is the ratio of vegetables to chicken? Okay, so we're going to answer that down here where it says solution, right? What's the ratio of vegetables to chicken? And we're going to write it as a ratio for now. So vegetables to chicken, so you go up and look for vegetables, and there's 5 cups. So for every 5 cups of vegetables, you have 3 cups of chicken. And notice that they're all in cups, okay? So you would put 5 to 3 or 5 to 3 like that. Okay. For B, what is the ratio of broth to vegetables? You say that there's 11 cups of broth, right? And there's 5 cups of vegetables, or 11 over 5 like that. And C, the ratio of chicken to rice. So there's 3 cups of chicken and rice is next, okay? Or 3 over 3, okay? Now you need to look at something. It's like, wait a minute, 3 to 3. When you see that, you can think of it as a fraction, right? You can divide both of them by 3 and then you get 1 over 1. You can do the same thing with a ratio. Divide this by 3, divide this by 3, and it's 1 to 1. We always want to try to reduce it. All right, Lucas, good. You're late, but it's better showing up. Thank you. So it's 1 to 1. We always want to reduce. These ones you could not reduce. You could not reduce, right? But this one you can. Okay. So D, let's answer. Those of you who just joined, go to page 15 in your booklet, okay? D is asking, what is the ratio of chicken to the total ingredients in the recipe? Okay, so chicken to total is basically what they're asking. So obviously there are 3 chicken, and this is a little, I don't like the wording, but total means everything, including chicken. Okay, so let's go back up and just add, let's see how many we have in total. If we go 11 and 5, that's 16, plus 3, that is 19, plus 3, that's 22 cups total. Okay, so we're going to put that down here for D. It's 3 to 22. Okay, I know some of you are saying, no, it should be 3 to 19, right? There's 3 chicken, 19 is the rest. I would be fine with that, actually. I would not dock you. Or 3 over 22. You could not say 22 over 3, guys, okay? The fraction, the first number goes in the numerator, the second goes in the denominator. It's very important for you to get that right. Okay, I'm gonna add something here, okay? Oh, maybe I will just highlight. This is for ratios. For ratio, right? The numerator can be larger than the denominator. That's okay. We don't convert it to a mixed number. Okay? And maybe another thing that I will mention is 1-to-1 like this. Usually we wouldn't bother writing it like that. But when we're dealing with ratios, I would. Okay? You could just say this is just 1, but for ratios, the way we're working with it, I would keep it like that. E, I'm going to add this. I'm going to write something down here for you to copy, okay? If Charles used 9 cups of rice. So write that down. If Charles uses 9 cups of rice. Okay, so let's say he makes his own batch, he makes his own soup, right? And in that mixture, he still wants to be consistent. He wants it to taste the same as the restaurant recipe. Okay? And he uses 9 cups of rice. So if you think about it, how many cups of rice did the original need? Let's go up once. We have, this recipe only called for 3 cups of rice. This large portion that's already large. So he's making a really huge batch here, maybe a big party, right? A big wedding or something that he's preparing a lot of soup for. So he's using 9 cups of rice. How many cups of vegetables would he need? And notice that it's E. It's still related to that question up there. You need to say, we're basically asking cups of rice to cups of vegetables. That's the question here. Cups of rice to cups of veggies, right? So we know based on the recipe up there that the cups of rice, there are 3 cups of rice there. We're just going to go 3 rice like that. Over how many cups of vegetables are in the original recipe up there? 5, right? So we're going to write it down like this because we're working with it now. And we're going to say that's going to be equal to, this is where proportion comes in. The 9 cups of rice, that is like your new recipe, that your new batch that you're making here. And notice that rice is at the top here. So we're going to go 9 rice here. And this is going to be our X. This is our unknown. That's how you solve these types of questions. Go and find out what is the mixture and the original. And now we're making a bigger batch. It could be a smaller batch. And let's find out X, right? And so we're going to cross multiply here. You don't have to worry about the units here, right? So 9 times 5 divided by 3. And that would be 15, right? And we know it's cups of vegetables. Okay, that is my answer there. Francis, I'm going to do attendance in a bit, okay? So you were asking about attendance. Okay, so this is my addition because it's just, this was all straightforward. It's like, well, how do we use those, right, to actually answer a question? So let's go to the next page here. Page 15. And that's build your skills, right? So we're going to build what we just learned here. and it goes until the next page. So what I'm going to do here is I'm going to do one more question, perhaps. You know what? I'm going to let you figure this out. I'm going to let you figure this out. Well, and if you're stuck, that's okay, but you need to give it a try, okay? Using the same method I just used in the question before this, try to answer. We're going to go 3, 4, right? Question 3, question 4, and 5 on this page. Let me see what's on the back side here. Yeah, let's just do 3, 4, and 5 on this page. I'll give you a couple minutes to do that, read it, and then we'll do it all together. In the meantime, I'll do attendance, okay? Okay. You gotta just give it a try, right? And then wait. If you're really stuck, just wait for me, okay? So here the question, they're giving you 2 ratios, right? Red to yellow, so this would be red to yellow, and this would be yellow to white, okay? So they're giving you 2 ratios, so you have to use the appropriate one for this. It's kind of like the soup, right? Veggies to rice or whatever. So there's a bunch of ratios. These are the 2 that you're known, right? So they're talking yellow and white here. So yellow and white, you have to use that one right there. So I always write it down like that as a fraction. And the 500 mLs is white ink, so that would go down here. And this is your unknown, okay? So white always go right, like the same variable has to be across each other. You can't have the 500 up there and then have yellow and white like that. It has to be lined up, okay? So basically you cross multiply this divided by 1. So it's 3 times 500 essentially divided by 1, not that it matters, and that's 1500, and we are in milliliters, okay, of yellow ink needed. Okay, so you would need 1500 milliliters of yellow ink if you wanted that to be consistent, that same shade as in the smaller batch, okay? All right. Same thing happens with your screen, okay? If you're on your small smartphone and you want to project that onto a big screen TV, there's a ratio that needs to stay the same or else the picture would look all weird, right? Okay, how many milliliters of red ink would she need if she has 750 of yellow? So we're talking red and yellow, okay? So 2 red, 3 yellow. How many of red, right? So they're already asking you that you know that X goes with red, and this would be 750 mLs, which is yellow ink, right? Oh, it's too much stuff if we have the mLs in there. I'd rather you make sure it's yellow and yellow, okay? Cross multiply and divide. So X is 2 times 750 divided by 3. So that's 1500 divided by 3, that's 500 mLs of red ink. Okay, needed. Let's try 4. I'm going to leave that there so you can write it down. So wait a couple of seconds so you can make corrections and then follow. Okay, on a bicycle with more than 1 gear, the ratio between the number of teeth on the front, so we're talking front, and the teeth on the back determines how easy it is to pedal. If the front gear has 30 teeth and the back gear has 10 teeth, watch what they're asking here. What is the ratio, right? What is the ratio? They're not asking you, you know, if it has this many teeth in the front, how many should it have in the back? Yeah, right? And the ratio is front to back, so it has to be stated in that order, front and back, like that, right? So we know that the front has 30 teeth and they have the same units, right? So I will actually do that with you. 30 teeth to 10 teeth. Okay. This is what happens when the units are the same, they get canceled. Okay. So you have 30 to 10. Okay. 30 to 10 is, you can reduce the trailing zero. So you just cancel this zero with that zero and it's just 3 to 1. We want it reduced. Okay. Always reduce, right? And just keep that in mind, because if you kept it at 30 over 10, you wouldn't get full marks there. Okay. So this is the ratio. They want you to write it like that. You could, or 3 over 1. That's fine. Okay. Normally when we talk ratios, I think of that. But when I work with it, I want it as a fraction. Okay. Some conveyor belts have 2 pulleys, right? So, right, if this is a pulley here and there's a pulley there, and the conveyor belt rides on those two, right? And if one pulley has a diameter of 45 centimeters and the other one of 20 centimeters, what is the ratio? So there it is again. What is the ratio? And how do you want them? What order do you want them in? Smaller to larger. Okay, so we're thinking of a ratio that's going to go small, large, right? And essentially this diagram is off, right? You're going to have one smaller and one is bigger like this. Okay, you're going to have a pulley like that, right? Like 2 pulleys here. It's the round thing that rolls, right? Keeps spinning. But it doesn't really matter it just read it carefully, right? So the smaller one is 20 centimeters, so we're going to go 20 centimeters. And the larger one obviously has 45 centimeters. Like just by looking at the numbers, we know which one is small and which one is large, right? We cancel the units, giving us this. Okay. And you know that 5 goes into both of them. So we go divided by 5, and that 5 goes in there 4 times. 5 goes in there 9 times. Okay. So that's essentially the ratio that we're after. Okay. So these 2 questions ask for the ratio itself. And this one up here, these 2 gave you a ratio, but they asked you to find another piece, right? So those are the 2 types of different questions that you can expect in this unit. Okay. So notice that this unit is also about currency exchange. So we're going to do that as well. Okay. All right. Bank tellers use ratios when converting currencies, right? You have 1 Canadian dollar equals approximately 1.13 Australian dollar, right? What is the ratio? There it is again. What is the ratio of Canadian dollars to Australian dollars? So they're asking, what would that look like in terms of numbers, right? If you had to put them like that. So they're both dollars, right? So we would say $1 to 1.13 like that. Okay. We don't want decimals, right? Okay, that's a big note here, no decimals. This is a start, but it's not done yet. How do you get rid of the decimal here? Maybe there's a brave volunteer in this class. Yeah. Multiply by 100, that's right. Because 100, right, those 2 zeros are going to shift this over twice. So in this case, we're going to multiply this by 100 and multiply this by 100 also. 1 times 100 is 100. 1.13 times 100 is 113. and that's what we want. Okay. So this is this is to emphasize the importance of no decimals. Okay. Next. 7. What is the ratio? There it is again. What is the ratio? The actual ratio of 250 mLs of grape to 1 liter of water. And they give you a big hint, right? Hint, convert both measurements to the same unit, right? Because 1 liter has 1,000 milliliters. I hope you know that already. It shouldn't be complicated, but how do we give this? What order do we give this in? Grape juice to water, right? So juice to water. That's the order in which we want that. So 250 mLs to 1 liter of water, which is 1,000 mLs. Okay, you want them both in milliliters. Okay, cancel the milliliters, first of all. And I hope you could see that trailing zeros can also be canceled. I know some of you are saying, I know something else. Well, go for it. I know that you see it. So this is really reduces to 25 to 100, just like that. And you should see that 5 goes into both of them, yes, but also that 25 goes into both of them. So I will divide both of them by 25, okay? And that gives me, I'm going to continue over here, okay? 25 goes in there 1 time and goes in there 4 times. So that is the reduced, right? So instead of saying the ratio is 250 to 1,000, you can just say the ratio is 1 to 4. It's much easier to work with. Okay. A mechanic mixes oil with gas to lubricate the cylinders in a motorcycle engine. He uses 1 part of oil and 32 parts of gas. What's the ratio of oil to gas? This one is, I don't know why this one is here, right? Oil, 1 part of oil, 32 parts. That's just another way of saying that whatever unit you use here, you have to have the same unit there. So if you were to use, let's say for instance, you mix 1 gallon of oil. If you have 1 gallon of oil, you would have to use 32 gallons of gas. If you have 1 liter of oil, you need 32 liters of gas. So that's all that. That's why they're using parts. Okay, and we're gonna move on there. Example 4. Tom and Susan make 180. This one is tricky, folks. Okay, so you gotta, whatever you're doing, pay attention now, okay? I will call this, I have a little subtitle here, Finding Parts Given the Total. You're gonna find parts of something given the total. It's a little tricky here. So you should be ready. You should be writing this down. We're on page 17. Right? Tom and Susan make $180 from holding a garage sale. Okay. This is your total. Because Tom contributed fewer items to the sale, the money is to be divided between Tom and Susan into the ratio 1 to 2, right? So you're basically Tom and Susan, right? So for every dollar that Tom gets, Susan would get $2, right? How much money will each person receive? So this is where you have to resort to a different strategy, okay? 1 to 2, right? You're gonna add those two together. 1 plus 2 is 3. So this number is what you're gonna split the total into. So watch what happens. We go 1 over, we take the 3 and plug it in there. So 1/3 times the total, right? Which is 180. So basically what happens here is 1 times 180 is 180 divided by 3. And what does that give us? That's $60. And I will call this per part. That's what I'm going to call this. So each part is equal to $60. So how would we find out how much Tom makes? Well, Tom, right, gets 1 part. How do we know that? Go back to the original. Tom only gets 1 part. So he would go 1 times 60, so he gets $60. Okay? Susan gets 2 parts. So we would go 2 times 60, so she would get 120. Okay? So I think the important thing is to remember that it still adds up to 180, right? That should be your check, right? Still equals 180. The total that is to be distributed among the people involved. So let me take you back, okay? Because I write it down and then I'm just going to walk you through one more time so that it sticks, okay? And if you remember this, I know for sure this comes back in grade 12 essential, okay? This kind of thinking. If you can wrap your head around it, then it'll be a lot easier then. Okay, here it is one more time. In this case, the ratio is 1 to 2. This could have been 2 to 3, 5 to 4, you name it. Write it down, add them up, then you get your total number of parts, right? So there's 3 parts. Okay. You convert it into a fraction, so it's 1/3 times the total. So this would be the total. Okay. And basically what it ends up being, whenever you go 1/3, it's just really dividing that number by the denominator, okay? Because it's 1 times 180 divided by 3, really. So then you find out how much it is per part, and then you go back to the original here and determine, okay, how much does that first person get? If this had been a 3, right, you would go 3 times 60, right? If this had been a 4, you would go 4 times, whatever the original ratio is telling you to split it up in that specific number of parts, okay? So tricky study sheet material, okay? I would put that in my study sheet, okay? And I would call it this, finding parts given total or something like that, right? And you may want to like shorten it a little bit, right? So that it doesn't take up all the space, but and maybe you want to add an example that you have in the next page that I'm going to ask you to work on. Okay, so let's flip to the next page here on 18. So this is a bit of a mix. So 9 to 11, I want you to work on that right now. And it's important that you try it. Okay, even if you get stuck, go to the next question, try that one. Oh, I can do that one. Okay, do 10 and 11 or do 9 and 11, whatever. But do these questions right now, and they kind of go back everything we've done so far. Okay, so give that a try. Build your skills on page 18. Another math class, that is. Okay, so here we have the first one is the ratio of flour to shortening in a recipe is 2:1. So just make sure it's shortening. Sorry, no, flour to shortening. Right? I just want to make sure, right? Flour to shortening is 2:1. And if a baker makes 30 cups of pie crust, how many cups of flour and shortening does he use? Okay, so basically what happens here is if it's a 2:1 for that pie crust and you make 30 of them, there's a couple things that you can do. You can either just add these two up like this again. So 2 plus 1, that'd be 3. Okay. And then you say that 1/3 times the 30 cups of pie crust, right? That would give you 10 cups because it's 30 divided by 3 essentially per part. Okay, 10 cups per part. So flour, right? Flour would be, in this case, flour is the first number, so it would be 2 times 10. So it's 20 cups for flour, and shortening, it'd be just 1 times 10, so it's 10 cups. Okay, and this still adds up to the 30 cups. Okay. All right. Next, we have that a compound of 2 chemicals, right, is mixed at a ratio of 3:10. Right? If there are 40 liters of this compound you made, how much of each chemical is there in the mixture? Okay, so again, 3:10. And let's say this is chemical 1 and this is chemical 2. Okay, and you're mixing it 3:10. Right? So how many parts are we talking in total? 13 parts. Okay? So you would say 1/13, right? Times 45 times the total. Okay, this is the total. Because they're not saying you have 45 liters of the first compound. Then it would be easy. Then it would just be a cross multiply and divide. You just say that the compound in total you have 45 liters, right? So basically it's 45 divided by 13, which is 3.4615 liters. And I'm not going to round too soon, right? Per part. Therefore, chemical 1, how much would I have of that? Well, chemical 1 has 3 parts, so 3 times 3.4615, you get something there. Chemical 2, that would be 10 times 3.4615, right? And I'm going to use my calculator just to double check. That's 10.38 rounded liters. And the next one is 34.62 liters if you round it. Okay. And if you add this up, you still get 45 liters. Okay, so that's a bit of a check we do to make sure we got that right. So this would produce, right? If you mix this much of chemical 1 and this much of chemical 2, you produce in total 45 liters, but you're still keeping this ratio the same. That's basically what you're trying to do here. Okay. And last one. Okay, Cheryl is an automotive repair technician. She mixes paint and thinner. Okay. To apply to the bus, instructions say to mix paint with thinner at 5:3. So paint to thinner is 5:3. If Cheryl needs 25 liters of paint, like it's a mixture, so that's the total, how much of each will she use? Again, add it up, you get 8. So it's 1/8 times the total. And that's liters. 24 divided by 8 is actually 3 liters per part. So in this mixture, each part is equivalent to 3 liters. So paint, you would go 5 times 3 liters, so that's 15 liters. And thinner, if you don't know what thinner is, it is what it is. It's a chemical, it's very strong. You mix it in and it just makes the paint a little thinner so it's not too thick, right? So 3 times 3 liters, so that'd be 9 liters. 24 liters total. Right, that's just a check that we do to see if we know what we're doing. All right, so we'll keep it here.